Can hear you.
Okay. Seems that still some participants are in the other meeting. I had some trouble with my laptop, therefore we set up a new Zoom meeting. Yeah, no, they're coming. We have some trouble with the Zoom meeting because somehow we got downgraded, so we only have a free account today. That means we have to reconnect after 40 minutes. So we will stop the meeting after 40 minutes and start a new one.
But we will use the same meeting, right?
Yes, so we're going to use the same meeting. Are there any new participants which never joined this meeting so far? If that's not the case, then we can start with the agenda. So today we have 3 topics. First, Swapnil will talk about etcd backup and restore optimizations. Then Prashant will talk about machine controller manager and cluster autoscaler enhancements. And then Uwe will talk about static etcd setup for Kubernetes master nodes. So Swapnil, you can start your part.
Yeah, hi Matthias. I'll just share my screen. Okay, are you able to see my screen?
Yes.
Yeah, okay. So yeah, this is first time we are presenting etcd backup restore component that we developed in Gardener community meeting. So I'll just quickly brush up through how we deploy etcd in Gardener. So what is the entire workflow? So first, we have Gardener controller manager through which we, for any incoming new shoot, will create a new custom resource definition called backup infrastructure. So this resource will be created per shoot, and as a part of backup infrastructure controller, which is a part of the Gardener controller manager, which will keep eye on these and associated with backup infrastructure CRD, it will create a bucket depending on the cloud provider for which the shoot is hosted, and this bucket will be created in the seeds infrastructure. So currently we support like backup on 4 major cloud providers like Swift, Amazon S3, or Azure and GCS. And once the bucket is created, then Gardener, we know bucket is created successfully, and credentials, the bucket name and those credentials are obtained for the bucket. Gardener deploys the etcd as a stateful set, where we deploy backup restore as a sidecar. So as a part of stateful set on etcd container, there you will find, people will find there is a small bootstrap script which calls backup sidecar restore to initialize the data directory. As a part of initialization initialization call backup restore sidecar will first check into the data directory on the PVC attached to the container, and it will validate it whether data directory structure is valid, whether the DB file is valid, and once it is valid, it will say etc to continue your bootstrap process, and etc will bootstrap. In case it is corrupt or invalid, we'll basically restore it from old backup. We'll go to backup bucket. We'll check whether there is existing previous backup. If it is there, we'll download it. Otherwise, we'll start the vanilla etc, which is generally the first time bootstrap. So once restoration is done, etc will be started, and after that the backup restore will set the readiness, set the health status okay. We'll take up we'll set the will expose true on the health API on backup restore, and which is used for readiness probe of this pod, this stateful set. And once the readiness probe satisfies, then obviously Kube API server, Kube API server will go with the further procedure.
Seems you're running out of battery.
No, so yeah, sorry, I connected the power. Yeah, so this was the overall flow till now. So okay, coming back to, sorry, I missed a point. Just to brief about how the backup operation happens. So currently on shoot, you could see there is a schedule parameter, which is like full snapshot schedule. So backup sidecar will take a full snapshot from etc, whatever configure parameter is. By default, we configure it to once a day, that is 20 after 24 hours. And there is another field called delta snapshot period. So backup sidecar will first take a full snapshot, upload it to bucket, and then apply watch on etc. And once the events are get collected based on the delta snapshot period, these events are collected in memory. And once the delta snapshot period is over, we'll push this as a delta snapshot on the S3 backing object store. And this process will go on. Once the again full snapshot schedule will trigger, it will take a full stop the previous watch, take a new full snapshot, and start the incremental snapshot restore. And as a part of restore, again it will search for the latest full snapshot. It will restore the data directly from that full snapshot, and over that it will apply the delta snapshot in sequential order, so that revision numbers, so it said revision numbers or it said event order, which was there in original DB, will not will stay as it is. So this is kind of backup restore. And at the same time, there is a garbage collection happening. So currently we have two policies. One is exponential and limit based. In Gardener, by default we kept to exponential, where we'll keep the backup for last hour. We'll keep the last full snapshot as well as the incremental snapshot, but before that we'll delete the incremental snapshot for whatever associated with different full snapshot, prior full snapshot. And the policy is like, so last hour we'll keep the latest full snapshot. Before that, within a day, for every hour we'll keep the latest full snapshot. For last 7 days, within a day we'll keep the latest full snapshot, and last 4 weeks we'll keep a full snapshot with the latest full snapshot per week. So this is how exponential policy was deployed. Yeah, so this is the overall flow, how the backup restore mechanism for etc happens. Yeah, so last week we released the version 0.4.0. So this mainly involved the fixes and optimization. This was more about optimization of the whatever processes involved in the backup restore mechanism. I'll go through one by one. So first was multipath. Previously, we were using simple snapshot upload command of individual cloud provider. Now we have multipath snapshot upload. So we'll take a snapshot, store it locally on temporary file, and then we'll upload it chunk by chunk. We'll use the multipath support from different cloud providers. And this way we actually saw there is indeed 40%, like significant around 40% improvement in the snapshot upload time. And this multipath upload will happen in, so we have internally at a time there will be 10, 20 chunks will be upload. So we have internally implemented pooling mechanism for this. Since every cloud provider SDK doesn't have their own way of managing, we had to implement it explicitly for every cloud provider. So this was on snapshot upload part. Then restoration part. Earlier, we used to, as I said, restoration, we will get the latest full snapshot, we'll restore from it. Then we fetch the delta snapshot in sequence, and we'll apply it over headset in sequence. This was the flow earlier. We just parallelized the, we added prefetching mechanism for delta snapshot. So we'll trigger a fetch of delta snapshot. So when first delta snapshot is getting applied, parallelly there is a fetch happening for other delta snapshot as well. Earlier it was sequential, so restoration was again taking little extra time. So we have some improvement over there. Next, probably big thing is so the how headset is implemented. So headset has this drawback of facing internal fragmentation. So as you have many majorly delete or update calls on headset, the DB size goes on increasing, though actual DB content is very less because of delete operation. Old key is supposed to be deleted. Since headset pass through internal fragmentation, you'll see DB size goes on increasing, and you will have this direct impact on headset memory usage as well, because headset memory usage is kind of proportional to DB size as well. So there we have defragmentation. Currently, there is no way on headset that we'll have defragmentation, automated defragmentation. So we have explicitly added defragmentation support. So let's say for by default it is configured to 3 days. So after every 3 days, we will trigger a defragmentation on headset. Yeah, this is costly operation because while defragmentation DB might be locked and you might not have update operation on headset, but I guess it is worth it. So for such interval, the defragmentation time period is very small, so you won't see actual any data loss or any network headset downtime when it is used as a backend for Kubernetes. And especially for Kubernetes, this is necessary because in case of Kubernetes, so let's say there are too many updates happening on shoot resources and pod deletion because of rescheduling or something. Pod deletion and deletion request comes very often. So there you'll see DB defragmentation fragmentation issues very often. So it is, I guess, necessary. It was necessary for Kubernetes. Apart from that, I guess there was one unhandled race condition in prior version that we have set up, George, that we have fixed with this. Then, as I said, a restoration. Again, there could have been one race condition. So earlier we used to delete the entire directory, same directory. You used to restore in the same directory which is used for headset, which is used as a headset data directory. So we used to clean up data directory and then apply restore operation, and it could have been case that the restore operation would have failed, and then there might have been wrong restoration or something kind of that. This is very rare, but one of the race condition in one of the case it might happen. So now we have changed the logic that we'll try to restore it on temporary data directory in parallel to the whatever headset data directory. So let's headset data directory is at headset /var/data. Then we'll restore it at /var headset data.part. And once restoration is successful, we'll replace the original directory with that. So this way, it helps in debugging perspective also. If in case restoration fails, what went wrong and why restoration failed. Apart from that, yeah, just small update that we had added profiling support in build Golang profiling support. So you can runtime so you can enable profiling support and hit a /profile endpoint on backup sidecar to check the memory and CPU and different consumption. Next thing, okay, that's it from 0.4.0. Next thing, we are actually progressing again with little enhancement. I guess we some improvements, like recently we could see PR Bekir from PTC. I guess he helped us adding Helm chart for the backup restore. And one of the other major advancement could be that we are now, initially, as I said, delta snapshot was taken only based on the time interval, but now we have again added support that, okay, if we cross the threshold memory limit, so since we were aggregating the watch events in memory, for a heavy workload, if you hit it with, which usually won't happen with when Etcd is backing KBAPI server, but you never know when you'll cross the memory limit. So we have added a memory threshold support. So in case the in-memory events cross the limit, let's say 10 MB, then we'll trigger delta snapshot. We won't wait for delta snapshot timeout. So comparatively, usually backup sidecar restore memory will be set higher than that, so higher than this threshold. So we won't face OM issue because of at least memory aggregation in memory. Yeah, these are the updates. So these memory support and this thing will release in next. This was not part of 0.4.0, but since we have already implemented, I thought it makes sense to add it in this presentation. And that's it from my side. Any questions?
Okay, if there are no questions, then you can unshare and Prashant can continue.
Yeah, sure. Thank you.
Thank you.
Okay, thanks, Swapnil. So I'm here to talk about the MCM and Cluster Autoscaler updates fleet. I hope you can see my screen.
Yes.
Okay. So some enhancements that are done or almost in review are so the MCM and Autoscaler now endorse the KTS version 1.12, and so that's better for us. So now both of them are like kind of compatible with one another more, and we did this to introduce some other changes mentioned below. So one is that we wanted to rebase the MCM with the MCM autoscaler, the forked autoscaler that we have with the upstream autoscaler. So we have a PR and it's about to be merged. So the reason why we did this was the upstream autoscaler had a lot of bug fixes. A prominent one was there was an issue where the autoscaler tried to taint more than the number of required nodes while a scale down. So you had a cluster and you were trying to do, the autoscaler was trying to scale down. It rarely went to the scenario where it tainted some nodes which were already running in the cluster. So this was fixed upstream, and we have created a PR, and we are almost in the process of merging that. And also, there's a PR for packet driver support I mentioned earlier by Deitch. I hope I got his name right. And this is the PR, and the final integration tests are running, and we are just looking for the integration test before it's being merged. And there's also a PR on metrics endpoint submitted by fsniper, and it's being reviewed by Dominic, and I guess the review is going back and forth, and hopefully this should be also in soon. These are some enhancements that will probably be a part of the next release version once MCM creates a new release. Something that we are also working on is we are trying to add this new feature where during machine updates, so machine controller updates during a rolling update, we plan to use this prefer no schedule taints on older machines. So this helps in the scenario where you're doing rolling updates, and when your rolling updates are going on, your workloads tends to keep rescheduling. And when this keeps rescheduled, sometimes it goes to the older machines which are going to be deleted again. So the downtime for your apps takes longer. So to avoid this, we want to introduce this so that it tries to schedule on the newer nodes during machine rollouts. So this is the issue for this, and we are working on this right now. And we are also working on to improving the deletion logic on Azure. So what we have observed is Azure takes too long to terminate running VMs. So one of the proposed solutions from Azure guys themselves in a ticket that we raised was to stop or power off the VM before terminating it, which will make it faster. And this is also something we're working on. And lastly, even Hardik has been working on for the gRPC drivers, because this is a larger change. He's been working on it. And hopefully, we should have something significant in very soon. And once this comes in, it'll be easier for us to support newer cloud providers, because all the cloud provider specific code can reside out of the main MCM repo, and we can just have different repos to maintain the cloud providers themselves. So these are some things in progress. And so that's for the updates from my side. Yeah. Any questions, any feedback?
Yes, I have a question about the rebase.
Yes.
For long term, will you keep rebasing, or is because as far as I know, upstream does not accept any more autoscalers?
Okay, for the cluster.
What's the plan from upstream?
So at least, so the idea is that right now, I mean, we have implemented the MCM as a cloud provider in the cluster autoscaler repo, and this is something that I don't think the community will be ready to accept it as a change. So what the plan is that we work with the forked version till the community itself comes up with its own version of autoscaler, which understands the cluster API, and soon, hopefully by then, MCM will also be cluster API compliant. And we are already working towards it. Even in the out of tree gRPC driver support, we are trying to bring in more, our APIs more closer with the cluster upstream cluster APIs. So the long-term goal is to merge with the upstream cluster autoscaler project and use their upstream autoscaler itself. This is just a temporary fork until we have consensus on the machine API in that sense. Does that make sense?
Yes, thank you.
Okay, thanks. Any other questions? Okay, if not, thanks.
Thank you. Hardik will in the next meeting. Hardik will talk about the out of tree support. So that's already on the agenda. If there are no other questions to this topic, then we can continue with Uwe.
Hi, do you hear me?
Yes.
Okay. We'll start with a short presentation, then a demo, show what we have achieved, and last I will explain a little bit more what's going on. So we start with an introduction.
Currently we can see you, but not your presentation.
Yeah, it's
coming.
Hopefully it's coming. Yeah. I'm still waiting for PowerPoint to come up. I don't know. Yes. Okay.
Oh, okay.
Okay. When we started the Gardener project, there was the need for some initial clusters, at least for the garden itself, but also for seed or soil clusters. Therefore, we started the Kubify project that should be used to create and maintain initial standalone clusters. Therefore, we decided to use Bootkube with the self-hosted etcd approach. Unfortunately, this decision causes a lot of trouble, and we definitely lost several clusters completely. Therefore, we were looking for an alternate approach and finally find this static etcd setup solution. The first step towards this was how to figure out what was the reason for those cluster losses. So we faced severe problems with the self-hosted etcd operator. The first one is the etc operator under unclear conditions destroyed the etcd cluster. It just removed it and said, okay, that's it. Unfortunately, the result is that the cluster is gone. Not so important and severe, but also disturbing was the fact that the etc operator somehow sets the completely healthy cluster to the fail state, and it cannot be recovered anymore, and you cannot do anything with the cluster anymore. It runs until it dies, and that's it. But the most important problem is something that results from a dependency cycle, especially for multi-node etcd clusters. We just call it the triangle of death. The problem here is that the etcd, multi-node etcd that consists of multiple members, requires kubedns for the member lookup. kubedns required the API server, and the API server for sure again the etcd. So whenever one of those components fails, the complete cluster is lost. Fortunately, we always had the recovery options, so we were able to recover the cluster again, but basically this was not a final solution. So we wanted especially to keep and to preserve the feature that etcd nodes are described as pods. We want to still manage get this managed by the kubelet, and it should be visible through the Kubernetes APIs. And for sure, we wanted to preserve the multi-node etcd cluster. If we have a multi-master node setup, we want to have also a multi-etcd node setup. But what we wanted to avoid now is the etcd operator because of its quality. The usage of the kubedns for the member connectivity is definitely not a good idea. And we want, as initially planned, avoid separately managed etcd clusters that require additional effort. So the result of this was the idea of using static pods on the master nodes managed by the kubelet. This is possible without the availability of a fully functional Kubernetes cluster. The final setup looks like.
Excuse me, we from Bangalore we have to vacate the building because of some drill, fire drill. So we won't be.
Just mute the phone. Okay, the final cluster looks at this. To avoid the kubedns, we use external DNS provider for maintaining the member names. For every master node has a dedicated DNS entry that is dynamically mapped to the appropriate IP of the VM. The VM itself uses a mounted volume that is used to host the etcd data directory and the Kubernetes directory. And inside this etcd Kubernetes manifest, we have the static pod definition with the etcd YAML. So the result is we have on every node, on every master node, an etcd member that together form a multi-node etcd cluster. So before I tell you more about this, how this can be achieved, we will see a first demo, what can be done. Or what
Uwe, can we first shortly restart the meeting because of the 40-minute timeout?
Yeah, sure, no problem. That's a good
I will stop the meeting and start a new one, and then we can reconnect.
It's
okay.
connected to the same meeting.
Yes, so we'll open the same meeting again.